Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and I'm here with my co-host Gary LaRue. And believe it or not, this is our 200th episode, and we have been publishing these videos for more than 8 years now. And there were times in the early years where we questioned if we'd continue the series, but now we see great buy-in from a wide variety of viewers and sponsors, and we get tens of thousands of views per episode, so we thank everybody for watching. So for this special episode, we thought we'd take a look back at a few clips from the early years and see how far technology and the industry have evolved. The first clip is from August of 2015.
One is a special report from Rohde and Schwartz. They're talking about meeting 5G test and measurement challenges. And the challenge is basically 5G isn't defined yet, so how do you test for it? There's no test system. So they basically provide some guidance in terms of how you can use commercially available test equipment to do the R&D necessary for 5G.
At this point, 5G standards were not defined, but testing has to lead the development of devices, so companies were putting together their current test equipment as best they could to at least get started on development of 5G devices, aiming for what they thought the standards would be. And the first release of 5G was the 3GPP Release 15 in the end of 2018. And now we're working on Release 17, which will be done this year, so it'll be the third release of 5G standards. We have standard 5G test systems available from a wide variety of manufacturers now, covering all the frequency ranges available to 5G.
Well, 5G was launched at the end of 2018 or early 2019, depending upon what criteria you use or which operator you listen to. If you remember, the timeline was actually accelerated by a year by adopting the so-called non-standalone architecture so that the LTE network was used for control and the 5G new radio for the user connection. And to get the proposed data rates for enhanced mobile broadband, the industry committed to actually using the millimeter wave spectrum, defining what's called the FR2 bands, which was the impetus really to commercialize millimeter wave. And while the most prominent use cases like autonomous driving and remote surgery are likely far off, 5G has had the fastest adoption of any cellular technology.
So the next clip is from November of 2014.
The cover feature there is very exciting research being done by one of our well-known millimeter wave researchers at NYU Wireless, Ted Rappaport.
Yes.
And so his people have done studies on propagation measurements at millimeter waves and have gotten some very impressive results. They did indoor and outdoor studies at 28 gigahertz and 73 gigahertz, and they present some of the path loss models and the multi-path spread characteristics. So if you haven't checked that out, you really should take the read through that because they're really interesting results for 5G technologies going forward.
Professor Ted Rappaport was pretty much the father of millimeter waves as he developed the first channel models at 28 and 73 gigahertz, showing that the propagation of millimeter wave signals was practical for 5G communications. Many people still doubted, even after his results, that millimeter wave would ever be viable for commercial cellular use, but today we are seeing it widely used in fixed wireless access, backhaul, and even directly to the smartphone. And I think there's still a few people today who doubt it, but I don't.
And I think Qualcomm actually gets the credit for putting millimeter wave in the phone. And this has really spawned a mix of companies, both established and startups, that are focused on the infrastructure side of the network. So Anoki Wave, Mixcom and Sivers now joined, Movandi, Otava, and established companies like Analog Devices and Qorvo. And supporting these startups and fabless design firms are foundries like Global Foundries with silicon germanium and high-frequency CMOS processes. And this creative design activity has really positioned SiGe as the leading process technology for millimeter wave infrastructure today.
So looking at the evolution of the RF industry, IMS 2014 seemed to be a watershed moment when leading up to and at the event there were several significant mergers and acquisitions.
Big announcement. Analog Devices announced that they will be acquiring Hittite, so that's a really big move in our industry. We talked with Vice President Peter Reel from ADI, and he told us how they have very good synergy. There's not a lot of product overlap ADI has always been very strong in the converter market and the synthesis and control market, and Hittite's very strong in the RF and microwave and even millimeter wave regions. So now they can really cover the whole signal chain and be a really strong player in all those markets. And also Hittite brings to them some of the defense markets. So
Okay, yeah, I was going to mention that as well. It was somewhat the news at IMS was the acquisition of Aeroflex by Cobham.
Right.
And coincidentally, they were right next to each other, conveniently on the exhibition floor. According to their press release, it was based on a move by Cobham to try to diversify more into the commercial market. And then we went to a press release.
Went to the Triquin, RFMD announced that merger right before we went. So RFMD had a press conference and they spent the whole time just talking about that merger. Of course, they knew that's all the press was going to ask about, so it was very smart of them to address that head on. So they spent a lot of time, again, showing how they have pretty much complementary products. We see that Triquin has a very strong presence in filtering technologies, defense technologies, while we have RFMD on the other side, a lot of good packaging technologies and silicon technology. So they're a very good complement. They said the merger will take place, be finished last quarter of this year, so we'll look forward to that.
And they refused to tell the name of the company. I think they're still working on it.
That's what we all want to know.
That was one of the questions, and then it will, be interesting. It'll be the last time we see RFMD and Triquin at an IMS.
So at the event, we found out that Analog Devices had acquired Hittite, which was kind of the beginning of ADI's acquisition run, which kind of continues today. Cobham announced that they would acquire Aeroflex, and the big merger of RFMD and Triquin was announced right before the event, and we didn't even know the name yet, so everybody was clamoring to find out that eventually it would be called Qorvo. So there were very impactful mergers going on in mid-2014, which is a trend that seems to be continuing, especially in the consolidation of the semiconductor industry today.
Well, you mentioned Analog Devices. After Hittite, they got Linear Technology and then Maxim. And recently, AMD acquired Xilinx, and Intel has acquired Tower Semiconductor. So the big firms are gobbling each other up. And on the technology front, in addition to the emergence of RF silicon, gallium nitride has really matured and crashed the cellular base station market. And I think there's no better confirmation of this than NXP's investment in a 100-millimeter GaN fab in Arizona.
So that was a good quick look back. So in the rest of this episode, we're going to be covering our March Cable and Connector Supplement. The cover feature is a cable and connector industry survey conducted by our own Gary LaRude. So Gary, what did you find out in the survey?
Well, it was interesting. We found out that although the pandemic affected the industry, there was a decline at the start, but it recovered quickly with overall growth in demand. The companies were challenged a little bit by having to manage supply chain issues, but that was pretty much across the board. Then we're seeing trends and opportunities, millimeter wave up to 110 gigahertz, and also higher density interconnects to support the higher density packaging and array architectures. And on this theme, an article from Times Microwave in the supplement discusses these exact market trends for higher frequency and high density multi-port RF interconnects. And then rounding out the issue, I'm sure many in the cable and connector industry feel they don't get the respect they deserve. Well, this article and application example should buoy their spirits. SSB Electronic writes a fascinating overview of what will be the first gravitational wave observatory in space, and it's called LISA. 3 spacecraft will be connected by laser beams to form a high-precision laser interferometer with laser arms that will be stretching millions of kilometers. One of the instruments is a charge management device being developed by the University of Florida, and it requires cable assemblies that have extremely stable phase, which SSB Electronic is supplying. It's amazing, the engineering and science in this mission.
So for products, we had a product feature from Junkasha on their new cable assemblies addressing the needs of 5G and operating to 145 gigahertz. And then we also had tech briefs on Huber and Sooner's highly flexible cables, Samtec's SMPM interconnects, and Mari Microwave's thermal vacuum chamber-ready cables. So Gary, you recently did an interview, correct?
Yes, earlier this week I had the opportunity to speak with Michael Cardulo and Chandra Gupta of Mini Circuits about their connectorized products. Let's watch a clip where Michael talks about the company's new capability at their Deer Park facility.
Our new design center is actually complete and operational at this point. We moved in a few weeks back. We have about a 10,000 square foot space up here. It's some office space, and it also includes a 3,500 square foot class 100K clean room. And we're really set up for full development and small scale production of microelectronic high frequency assemblies. So we have full simulation and modeling capability here, the typical full wave electromagnetic simulation, circuit simulation, analog and digital capability on site in Deer Park. And we really are focused on a lot of the higher frequency connectorized assemblies. So most of our designs will be chip and wire based designs, and we use die attach with conductive adhesives, electrically and thermally conductive adhesives. We have a lot of the industry standard wire bonding capability, ball, wedge, wire, ribbon, and then of course full test capability up to 110 gigahertz. Both on the development side and on the production side at this point, we have multiple 110 gigahertz setups functioning. So we really are a fully functional technology development center out in Deer Park.
So it was very interesting to learn about mini circuits work in the high frequency, high power amplifier area. I didn't know they were doing that much in that area. So there was a ton of news coming out of the satellite show from DC, including Kymeta signing an agreement with OneWeb to distribute LEO satellite connectivity services. Ball Aerospace was teaming with Flex for production of a cost-effective flat panel antennas, and Ball also teamed with Stellar Blue Solutions to bring a series of Ku-band SATCOM terminals to in-flight connectivity. And Swiss to 12 worked with Thales to develop a Ka-band SSPA for the European Space Agency Aramis program. Mission Microwave confirmed the initial production orders for their high-power SSPAs in support of SES. Hughes was selected to deploy a private 5G network for the DoD. And finally, Isotropic Systems had several announcements, including the first military standard Ka-band terminal range and plans for the commercial launch of their arrays. So Gary, what did you see in the news?
Well, I'll add one on the satellite front. OneWeb has tapped SpaceX to launch the last of the 220 satellites in its LEO constellation after it terminated its relationship with Russia following the invasion of Ukraine. Unfortunately, OneWeb prepaid for the last 6 launches, and Russia says it will keep the money. It's also interesting that SpaceX is launching its own LEO constellation, although I would say they are quasi-competitors. The two systems are really targeting different markets.
So turning to events, I just returned from the satellite show in DC, so that's why I had all the space news. And it was very well attended. I think everybody's kind of just coming out of the COVID routine and starting to get back to trade shows, so it was very well attended. The most interesting things I saw were the continued development of the millimeter wave flat panel arrays, and also there were several 3D printed RF products. The millimeter wave flat panel array systems approaches are continuing to expand. There are several companies now using metamaterials approaches, and there were even more companies that I saw developing active electronically steered arrays. So it'll be really interesting to see who can go to large-scale production on these first. For the 3D printed components, we are seeing several companies doing waveguide structures and others doing antenna arrays. So 3D printing really gives you the flexibility to form any kind of shape structure, so it enables new capabilities for designs in the RF area.
Well, the satellite show seems like it was very vibrant, judging, although I wasn't there, judging from the number of releases that came out. And we're looking forward to European Microwave coming up in the first week of April in London, and hoping we'll see many of our European colleagues there. And that wraps up this episode of Frequency Matters. We want to thank our sponsor, Mini Circuits, an industry pioneer and global supplier of RF microwave components, integrated assemblies, and test and measurement equipment. 200 episodes is quite a milestone. We wouldn't have made it this far without the constant help of Coulter and the team at Matter, who handle the production details and edit out our mistakes so we look our best. Coulter, you have our undying support. And thank you, our watchers, for watching, because you are the reason we do this. We really appreciate your loyalty. We'll be back for episode number 201 in a couple weeks from London.